So today should prove to be interesting for me. And try something different. It's not exactly how I normally teach it, because I saw something when I was planning it and I thought, oh, this would be great. So we're going to try something different. But you'll be okay with it because you don't know the way I normally teach it. So the second law of exponents has to do with division. Any number raised to the n power divided by that same thing raised to the nth power is equal to a, or that same thing raised to the m minus n. So when you divide like bases, you end up subtracting your exponents. Let's look at why that's so. If I were to have 2 to the third divided by 2 squared, on top that looks like 2 times 2 times 2, and on bottom that looks like 2 times 2. We learned a long time ago when we were dealing with fractions that if you have the same thing on top that you have on bottom, they can cancel each other out. So that just leaves us with a 2 on top. In other words, if I had 2 to the third over 2 squared, I would say that's 2 to the 3 minus 2, because 3 is on top and 2 is on the bottom, so it's 3 minus 2. And 3 minus 2 is 1. 2 to the 1 is just 2. So you end up with the same answer. Now, I realize this looks like it's easier to do because it's fast and quick and simple. But when we get really big numbers down here and large exponents, you don't want to have to list them all out. It's easier just to have a rule, which is what this is. It's a rule to deal with it. Let's say we had something different. Let's say we had y to the 6th over y to the 3rd. Well, that's going to give us y to the 6 minus 3, which is just y to the 3. Simple, easy, and quick. Okay, let's say we had y to the 2 over y to the 5. That's going to give us y to the 2 minus 5, which is y to the negative 3. Does that negative 3 make you feel a little bit uncomfortable? It should. We don't like having negative exponents at all. Negative exponents should not be left in your answers. Negative exponents are bad. We don't want them to be negative. But wait, there's a fix for that. It's this rule right here. It tells you how to take care of a negative exponent. You can take care of it by flipping it to the other side. Negatives here don't mean the same thing as negatives out front. It's a completely different kind of negative. Negatives here mean it's going to the other side. That other side means it's going to the upside down. That's right. I just tied it all in with Stranger Things. This negative exponent operates just like going in and out of the upside down operates. When you have a negative exponent, it has the power, because it's a power, I know this is cool, right? It has the power to shift it into the upside down. But if you have a negative exponent in the upside down, that negative exponent has the power to shift it to here too. So it can come up top. Now the reason I put a 1 underneath is not because of this one, it's just to say that there's something down there so you knew it was on top. Now, a lot of times they don't tell you that it's on top. See, right here, we didn't say that this was over anything, but you and I know that it's over something. It's not just y to the third, it's y to the third over 1, because there was nothing there. But if you want to show there is something there, that's okay. But this one is not there because of that one. That one is there because there's always something on the bottom. There's always something in the upside down. We just don't always know what it is. So, let's try some harder ones. These right ones on this board anymore. Okay, let's say we have 2 over x to the negative 3 and then 4a squared b to the 5th over 2a to the 6th b squared. We don't like this way because it has a negative exponent. Whether the negative exponent's on top or on bottom, it does not matter. We don't like negative exponents. So we can take care of that negative exponent by sending it to the other side. When I send it to the other side, it doesn't change the number. It only changes the sign of that number. So instead of it being a negative 3, now it's going to become a positive 3. My 2 didn't move. It was already positive, so it didn't need to move. Just my x to the 3rd had to come up because it was a negative exponent. Now I know you're saying that x wasn't negative. Why did it have to move? Well, that's what it was an exponent for. You can't move an exponent without moving what it was an exponent for. So the x had to go up. Down here, we don't have any negative exponents. So I'm all good just to go ahead and do our calculations. Now, I do not say 4 minus 2. Because 4 minus 2 may give me 2, but that's not what it's doing. It's talking about division. So my big numbers still have to be divided. 2 goes into 4 2 whole times. Then I can start my other calculations. Like bases means I subtract my exponents. So that'll be a to the 2 minus 6. And then like bases mean I subtract my exponents, b to the 5 minus 2. So that's 2. 2 minus 6 is negative 4. And then 5 minus 2 is a positive 3. Remember, we don't like negative exponents, so we have to send them into the upside down. So that'll be 2b to the 3rd over a to the 4th. When I send it into the upside down, that's when it becomes positive. If it's already in the upside down, then when it comes up, it'll change into a positive. Going in and out of that upside down, that's what changes the exponent sign. Let's talk about another rule that was on your list. It was any number to the 0 power is equal to 1. It doesn't matter what it is. Any letter, any number to the 0 power is equal to 1. So let's look at this problem. Negative 12 k squared m to the third n over k squared over 9 m cubed n to the sixth k to the fifth. The first thing I'm going to do is take care of my big numbers in front. Because remember, we're just dividing these. Now I know you're thinking the 12 has to move to the other side because it's negative. But it doesn't matter that it's negative. The only thing we have to worry about is negative exponents. And this doesn't even have an exponent, so it can't matter that it's negative. This negative out here has nothing to do with negative exponents. They don't mean the same thing. They don't operate the same. So here, 12 and 9 can be reduced. Can't go into it evenly, but it can be reduced. What goes into 12 and 9? 3. 3 goes into negative 12, negative 4 times, and 3 goes into 9 3 times. So now I've got my line. So that's good. Only I don't want to stress my line right now because I have all these things I need to calculate. And since I'm not going to show it in my head, I'm going to show it on some paper for a little while. So I have 2 on top minus 5 on bottom. Remember, the number on top has to always come first. So the top exponent comes before the minus 5. And then we have m. So my top exponent is a 3 minus a 3 on the bottom. And then n, my top exponent is a 1. Don't forget that there's a 1 there. Minus a 6 on the bottom. So that's negative 4 over 3, k to the negative 3, m to the 0, n to the negative 5. Now I'm ready to do some upside down stuff. So the k has to get sent into the upside down because it has a negative 3. So when I put it down here, the negative goes away and it's just k to the third. M to the 0 means that it's 1, and any number times 1 is just that number. So I don't have to write it down at all. It's gone. Because 1 times all this stuff is just going to give us all this stuff that I'm writing down. N will have to go to the bottom because it's got a negative exponent too. So if I were going to write it prettier, I'd make it look like this. Pretty makes it easier to understand, doesn't make it any more correct. Okay. Positive exponents stay where they are. Negative exponents are the ones that have to move. Over here, positive exponents stay where it was. Negative exponents are the ones that have to move to the other side of the upside down. So it's either going to go up if it was on the bottom, or it's going to go to the bottom if it was up. Okay. Let's talk classwork and homework. Practice exercises. Page 232. Numbers 1 through 15 odd. Still only 8 problems, so don't stress it. These answers are going to be in your book. Your mom's not going to have a copy of them because they're in your book. So make sure you check your book before you continue to do the homework. Same practice exercises. Same page. Numbers 21 through 35. Odd. Still, only 8 problems. So you're covered. And you'll see me tomorrow.